Hello everyone, welcome to my YouTube channel. I am Dr. Injamamul Haq, currently working as an assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. In today's lecture, we will study a fundamental concept of probability and statistic theory known as random variable. This topic is extremely important because it forms a foundation for all the probability distribution such as binomial distribution, Poisson distribution, normal distribution, T distribution and F distribution. So I strongly recommend it to all of you watch this video till the ends. So let's start our topics random variable. If you toss two coins simultaneously, then the total possible outcomes are what? Head head, head tail, tail head, tail tail, right? Then we can see that these outcomes are non-numerical in nature. But in case of probability and statistics, we are preferred to work with numbers because we find the probability, we calculate the mean and variance, we perform on mathematical operation. So naturally there is a question, how do we convert these outcomes into the numerical value? This requirement lead us to the concept of random variable. A random variable is a function that assigns a numerical value to each outcomes in a simple space, right? So let us understand this definition by taking numerical examples. If you toss two coins simultaneously, then the total possible outcomes is equal to what? Head head, head tail, tail head, tail tail, right? Okay. And if you define a random variable x from s to r as what? X of s is equal to the number of head, right? Number of head. Then we will write as what? Here we will write outcomes. Here we will write the value of x, right? If the outcomes are head head, then the value of x, that is number of head, will be 2. If it is head tail, this is equal to the 1, tail head, this is equal to the 1, and tail tail, this is equal to the 0. So instead write this outcome as a head head, head tail, tail head, tail tail. We can write this one as a what? 2 1 1 0. We can see that this is simple and more systematic. That's why we study the random variable. So now we understand the concept of random variable. Now we formally define the random variable. So the random variable, let S be a simple space of this random experiment. A random variable x is a function from S to R which assign a real number xs to each s belong to the s. As this is a function, so also we can define a range or space of this random variable, okay, of this random variable, because the set x belong to the R, x of s is the set x belong to R such that each element which is associated with the random variable is called the space or range of this random variable. So now let us take another example which illustrates the definition of random variable as well as the space and range of the random variable. Consider the coin tossing an experiment. Construct a random variable x for this experiment, and what is the space or range of this random variable x. So now for this random variable, the simple space will be what? S is equal to head and tail, and we can define the random variable x as a what? For head this is equal to the 0, and x of tail this is equal to the what? 1. This is equal to the 1. So we can see that this is the valid map by our definition, and it is also a random variable for the coin tossing experiment, and the space for this random variable will be equal to the what? Rx is equal to 0 to 1. Rx is equal to 0 to 1. So now we understand the concept of random variable. Now we will discuss about the different type of random variable. So random variables broadly classify in two categories. First one is the discrete random variable, second one is the continuous random variable. So let us discuss the each types of random variable one by one. First we will discuss about the discrete random variable. So what is discrete random variable? The discrete random variable is what? If the space of random variable is countable. Means what? If x is either finite or countably infinite, which can be listed, so that is called countable set, and if this is countable, then the corresponding random variable is called discrete random variable. So let us understand this definition by this example. Consider a random experiment in which three pair coins are tossed simultaneously and each coin get result in either head or tail. Okay, so let us discuss. Here the total possible outcome for this random experiment, whenever we toss three coins simultaneously, we will get the total simple space as a head, 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 tail. Now head, tail, head. Now tail, head, head. Now tail, tail, head. Now tail, tail, head, head. Now head, tail, 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 tail. 1, 2, 3, 4, 5, 6, 7, 8. These are the total possible outcome when we toss three coins simultaneously. And if we define the random variable x of s is equal to the number of heads, right? Then what is the range or space of this random variable? Will be equal to what? For these three, this is 2, this is 2. For this is 3, this is 2, this is 2. Here this is 2. Here 1, here 1, here 1, and here 0. So the Rx will be what? 3, 2, 1, 0. So as we can see that the space or range of this random variable is a finite. So this is the countable set. That's why whenever we toss three coins simultaneously, the corresponding random variable will be equal to what? Will be the discrete random variable. So now we understand the concept of discrete random variable. Now we will discuss about the continuous random variable. If the space of random variable is countable, then this space is called continuous random. Then this space is called continuous random variable. That means continuous random variable is related to the uncountable set. Okay. Why? Then that means if the value is takes from the interval or any uncountable set, then we can say that the given space of random variable will be continuous random variable. And the probability for the exact value in case of continuous random variable is 0. Okay. So now we will discuss an example related to the continuous random variable. In a class, the height of the student vary between 4 feet 6 feet. Suppose one student is selected at a random from the class and let x be the height for selected student. State whether x is a discrete or continuous random variable giving region and write the space or of this random variable x. So as we can see that here x omega means what? The space or range of this random variable equal to what? The collection of x such that this x lie between what? 4 to 6, right? So we can see that this is the interval and we know that interval are uncountable sets. That's why this is space of random variable will be continuous random variable. Why? Because this the value comes from the interval and interval is always uncountable sets. That's why this given space of random variable will be continuous random variable. So now we got the definition of continuous random variable. So now we will discuss about the probability distribution. Okay. So probability distribution basically describe how the probability are assigned to the possible value of random variable. Let us illustrate an examples related to the probability distribution. Consider you tossing a fair coin and let the random variable x represent the outcomes as x is equal to 0 for tail and x is equal to the 1 for head. Okay. So now we will find the probability corresponding to each value of x is equal to 0 and x is equal to the 1. The probability distribution P of x is equal to 0 equal to 1 by 2 and P of x is equal to 1, this is 1 by 2. That's why the probability distribution may also be expressed in the tabular form as shown in below. Here we can see that for x is equal to 0, probability corresponding to that x is equal to 0 equal to 1 by 2 and probability x is equal to 1, this is equal to the 1 by 2 again. Okay. So now this is all about the probability distribution. So now we will discuss a numerical example flipping on two coins, right? So what is given in this question? Suppose a simple game involving the flipping two fair coins simultaneously. In each coin land either as a head or tail, right? Head or tail. The outcome of this experiment depend on the combination of the result obtained from the two coins. First is what? First question is write down the simple space for this random experiment. Define a random variable that represents the number of heads obtained in a single trials. Find the range of this random variable x and determine the probability distribution of x. So this is the question. Now let us solve this question. So first we will find the simple space. Simple space for this random variable will be equal to what? S is equal to the head head, head tail, tail head, tail tail, right? Okay. So now define the random variable as a x from s to r such that f of x is equal to the number of head in the outcome s. Then the value at x head head equal to 2, x head tail equal to 1, x tail head is equal to the 1 and x tail tail is equal to the 0. And range of this random variable in the will be what? The possible value assumed by x are equal to 0, 1, 2. We get here from. Okay. So now we will find the probability distribution corresponding to the each value of x. So P of x is equal to 0 equal to means what? Probability corresponding to the getting exactly two tails, right? So this is equal to what? X is equal to 0 means what? There are no heads. That means you have to find the probability corresponding to TT. So this is equal to the 1 by 4. Probability of getting x is equal to 1 means probability of getting exactly one head. That is outcomes are head head, head tail, head tail and tail head. So this is equal to the 2. That's why the probability corresponding to x is equal to 1 equal to 2 by 4. So now for x is equal to 2 means what? Probability of getting exactly two heads, this is equal to the 1 by 4. So now we understand the concept of probability distribution. Also you can solve different type of problem based on the probability distribution. So now we will discuss another example, rolling two dice. Okay. So in a board game, a player is required to roll two fair six-sided dice simultaneously. Each die shows a number from 1 to 6. The outcome of this experiment is recorded as an order pair A, B, where A is the number on the first dice, B is the number on the second die, right? And also you have to given the total sample space. S is equal to what? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Similarly, you can write 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 4, 3 5, 3 6. And the similarly, the last one will be 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. With the simple space of this experiment, and also define a random variable f that represent the sum of the number appearing on the two dice. Now question is what? Define a random variable which is already given, and then range of this x and determine the probability distribution corresponding to the value of x, right? Now first, what is the simple space? Simple space equal total number of simple space will be what? 36. So we will write this simple space as a S, and S is equal to the collection of AB such that A comma B lie between 1 to 6, right? And already in a question the random variable is defined as the sum of number rolled on two dice. That means for each outcome A comma B belong to the S, the random variable X is given by X of AB equal to A plus B, A plus B, where A and B are the number rolled on the first and second die respectively, right? So now, what is the value of random variable, range of this random variable? The possible value of X range from 2 dice to up to 12, because we can see that the 1 1 is what? The sum of 1 1 is what? 2, and sum of 6 6 is what? 12. So the number is lie between what? The range of this random variable will lie between 2 to 12. That is 2, 3, 4, 5, 6, 7, 8, 9, 8, 10, 11, 12. Okay. So now we will find the probability distribution corresponding to the each value of X. That is, for X is equal to the 2, this is equal to 1 by 36, X is equal to 3. That is what? The sum is equal to 3. This is only 1 comma 2 and 2 comma 1. For X is equal to the 4, that is the numbers will be what? Outcomes will be what? 1 comma 3, 2 comma 2, 3 comma 1. So this is 4. So this is equal to what? 3 by 36. This is equal to 1 by 12. In the similarly, we can find for each value of the range space of this random variable, and also we can see that for 12 this is only 1, this is the outcomes are only 6 to 6, okay, and the sum of this number is 12. That's why this is the only one number, so this is equal to 1 by 36. Okay, so this is all about the probability distribution. Now there are some exercise question, you can solve these questions. If you have any doubt or problem, also you can comment. I will provide the answer or solution of these questions. So now we will discuss about the two important terms which will be used in our next video, that is probability mass function and probability density function. Basically, probability mass function is related to the discrete random variable, and probability density function is related to the continuous random variable. So now one by one we will discuss about this. First we will discuss about the probability mass function. What is probability mass function? Probability mass function is a function which gives the probability of discrete random variable X, taking a specific value on X from that random variable, and which satisfies the two conditions. First condition is P of X is greater than or equal to 0 for all X belong to R. This is also called non-negativity, and the sum of all the probability, that is what? P of x1 plus P of x2 plus P of x3 up to 1 P of xn equal to 1. If in a random variable there are n number of elements, that is x1 x2 up to xn, then the sum of all the probability corresponding to each element x1 x2 xn equal to the 1, and this is also called normalization property. If these two properties are satisfied, then we can say that this function px is a probability mass function. So probability mass function is basically related to the discrete continuous random variable. Okay, now discuss an examples related to this distribution, related to this function. Let x be a discrete random variable which is defined on x is equal to 1 2 3 4. Now the probability mass function is given by P of x is equal to x by 10, x is equal to 1 2 3 4, and this is 0. Now we will show that this is the probability mass function. So we will show the two property. First property is what? P of x is equal to greater than 0. We can see that because this is equal to the x by 10 and x is equal to 1 to 4. So this is always strictly greater than 0, and for otherwise this is equal to 0. That's why P of x is always greater than equal to 0. Now we will find that P of 1, this is equal to what? 1 by 10. P of 2, this is equal to 2 by 10. P of 3, this is equal to 3 by 10. P of 4, 4, this is equal to 4 by 10, right? If you add these all probability, we will get that this is equal to the 1. This is equal to the 1. Since P of x is greater than 0 and sum of all the probability equal to 1, the given function is probability mass function. So now we understand the concept of probability mass function. Actually, this terminology will be used in our next video, which will be about the expectation and variance. So now we will discuss about the probability density function. What is probability density function? Probability density function is a function which describes of a continuous random variable taking on a specific value x. That is, probability density function gives the probability at the point of discrete, at the point of continuous random variable, which satisfy the two conditions. First condition is all about the non-negativity, that is f of x is greater than equal to 0, and second condition is what? The integration from minus infinity to infinity f of x dx equal to 1. This is called normalization. Actually, this is the uncountable set, that's why here we will use the integration from minus infinity to infinity f of x dx is equal to 1. If these two conditions are satisfied by this function, then we can say that these functions are called probability density function. So basically probability density function is related to the uncountable set, that is continuous random variable. Okay. So now let us discuss an example related to the probability density density function. Let x be a continuous random variable with the density function f of x equal to what? 2x, x lie between 0 to 1, and this is equal to 0 otherwise. So now we will see that f of x is greater than equal to 0. Why? Because this is equal to the 2x for x lie between 0 to 1, otherwise this is equal to the 0. So first condition is satisfied. Now for the second condition, we will say that minus infinity to infinity f of x dx can be written as what? Minus infinity to 0 f of x dx plus 0 to 1 f of x dx plus 1 to infinity f of x dx, right? So here you can see that what is the value of this function minus infinity to infinity, this is equal to 0 given here, right? So first will be what? This is equal to the 0. Second one equal to what? F of x is equal to, for x lie between 0 to 1, this is given to you 0 to 1 2x dx, and next term equal to 0. So now when we integrate these terms, we will get that 2 of x square by 2 0 to 1. So this is nothing but 2 into 1 by 2, this is equal to the 1. That's why here we can say that this function satisfy the two conditions. First condition is f of x is greater than equal to 0, and second condition is what? Minus infinity to infinity f of dx equal to 1. That's why the given function is a probability density function. Okay. So now wait for the next video. In the next video we will discuss about the expectation and variance. If there is any doubt, also you can write a comment there. I will try to solve your doubts. Thank you.